So this darker curve in blue is the graph of r is equal to 1 minus cosine of theta. Of course, we're dealing in polar coordinates here. And what I'm interested in is to see if we can figure out the area enclosed by this curve. And I encourage you to pause the video and try it on your own. All right, let's work through it together. So we've already given ourselves the intuition for the formula that the area enclosed by a polar graph is going to be equal to 1/2 the definite integral from, you should say, our starting theta to our ending theta, from alpha to beta, of r of theta squared d theta. And so we essentially just have to apply this to this function right over here. So in this case, the area is going to be equal to 1/2 the definite integral. Now, what's our alpha and what's our beta? Well, we're going from theta is equal to 0 radians, and we're essentially going all the way. When theta is equal to 0 radians is 1 minus 1. We're right over here. And then we go all the way around to theta is equal to 2 pi radians. Notice when we're back at 2 pi, cosine of 2 pi is 1. 1 minus 1 is 0 again. So we get back to that point. So we're going from theta is equal to 0 radians to theta is equal to 2 pi radians. Now, what's r of theta squared? Maybe I'll color code this a little bit. R of theta squared. Well, it's just going to be 1 minus cosine of theta. 1 minus cosine theta squared. And of course, we have our d theta. And now we just have to evaluate this integral. So once again, at any point you feel inspired, try to evaluate this. So let's do this. All right. So what I would do, so this is going to be equal to 1/2 times the definite integral from 0 to 2 pi. And let me expand this out. This is going to be 1 minus 2 cosine theta plus cosine squared theta d theta. Now, I know how to take the antiderivative of 1. I know how to take the antiderivative of negative cosine of theta. But cosine squared theta, this is a little bit, it doesn't jump out at you that you can just use u substitution or something like that. But lucky for us, we have our trigonometric identities. And so we know that cosine squared of theta is just the same thing as 1/2 times 1 plus cosine of 2 theta. You learned this in trigonometry class. If you didn't, well, you learned it just now. And so that's why, well, this is one of the more useful trigonometric identities if you're finding any type of antiderivative, or if you're integrating anything. And so let's do that. Let's rewrite this right over here as 1/2 times 1 plus cosine of 2 theta. And let's see, and maybe we could, well, yeah, let's just do it like that. I guess we could if we want. Well, we'll just do it like that. So this is going to be equal to 1/2, and then we are going to 1/2. Now let's just start taking antiderivatives. 1/2. Now the antiderivative of 1 with respect to theta is just going to be theta. The antiderivative of negative 2 cosine of theta, well, that's just going to be negative 2 sine of theta. Negative 2 sine theta. You could take the derivative. The derivative of sine is cosine. And the negative 2, it'll just multiply it times the derivative of sine of theta. So it's negative 2 cosine of theta. And then we're going to have, let's see. Actually, let me distribute this. This is the same thing as 1/2 plus 1/2 cosine of 2 theta. So let's just assume, well, it's this way. So the antiderivative of 1/2. So the antiderivative of 1/2, so I'm really looking at that right over there, is going to be 1/2 theta. 1/2 theta. And then the antiderivative of 1/2 cosine of 2 theta, let's see. The derivative of sine of 2 theta is 2 cosine of 2 theta. So this is going to, so the antiderivative is the antiderivative of cosine of 2 theta. And you could do u substitution if you like, but you might be able to do this in your head. The antiderivative of cosine of 2 theta is going to be 1/2 sine of 2 theta. And then you have this 1/2 right over here. So this is going to be, let me show you what I'm finding the antiderivative of that right over there, of this, and I guess this right over here. This is going to be plus 1/4 sine of 2 theta. And I encourage you to find the derivative here if that last part was a little bit confusing. Derivative of sine of 2 theta is 2 cosine of 2 theta. 2 over 1/4 is 1/2. You get to 1/2 cosine of 2 theta. And we're going to evaluate that at 2 pi, and at 0. So when you evaluate it, well, one thing that might jump out at you is when you evaluate this at 0, whole thing is every term here is just going to be 0. So that simplifies things nicely. So we really just have to take 1/2 of it evaluated at 2 pi. So this is going to be 1/2 times 2 pi, and then sine of 2 pi is 0, so that's just going to be 0. And then plus 1/2 times 2 pi, so that's going to be plus pi. And then sine of 2 times 2 pi is sine of 4 pi. That's still going to be 0. So this is going to be 0 as well. And we are almost done. So this is going to be 1/2 times 3 pi, or 3/2 pi is the area of this region.